Now we are tying up this unit with our last little bit of dimensional analysis, and for that what we want to do is we want to talk about some double conversions. Up until this point, we have always seen that we just had something in the numerator, and then if we were just a little uncomfortable with nothing in the denominator, sometimes we threw in a 1. But now what we're going to see is that we have units in the numerator and the denominator. So for example, if we had 60 miles per hour, the way you need to write this down to make dimensional analysis work is make sure that you put miles in the numerator, hours in the denominator. Do not write MPH. That's not going to work with dimensional analysis. Do not write miles/hour in the numerator. That's not going to work with dimensional analysis. So make sure you're real clear about where you put your units. Okay, for this, you're doing exactly the same thing, but not only do you have to do it for the numerator, you also have to do it for the denominator. And what I like to do is just do them independently. So for example, I read through this first question. It tells us our average speed of an orbiting space shuttle is 17,500 miles per hour. And what we want to do is convert that to kilometers per second. Especially when you have these 2-unit conversions, it makes it really helpful to write this out up front. I'm not ever going to grade for that. If you didn't do that, I wouldn't mark it wrong. But it sure helps to guide you as to what you want your units to be at the end. So now I know that I'm starting with 17,500 miles per hour. Hey, how many sig figs are we going to have in our final answer? How many? 3. So I am looking right here. Remember, this first thing that I write down is always going to tell me how many significant figures I have. Okay, I am a creature of habit. It does not matter what you start with, but I tend to look at this numerator right here, my kilometers, and that's what I'm going to start with. In other words, I'm going to start with the miles. I'm going to start with the distance here. It does not matter which one you start with. In doing so, I'm going to completely ignore the denominator, so I'm not going to think about the time at all. So I'm just going to focus on my miles, and I know I want that to cancel out. So in order to make that cancel out, where do I put it? Bottom. I want to go to kilometers. Can we do that directly? Yeah, there it is right there. That conversion factor is given to us. That is not one that you're expected to memorize. It's given to you. So we want to go from miles to kilometers. Easy enough. Make sure you grab the correct numbers and put them with the correct unit. So with the kilometer, what number are you going to put? Good. And that means the 1 goes with the miles. So now I see that my miles cancel out. Yippee! I'm left with kilometers in the top. I am done with the distance part of this. I have got that finished. Everything worked out perfectly. So now all I have to do is think about the denominator, which happens to be time. So I want to get, if I stopped right here, I would have my final answer as kilometers per hour. So what I need to do is get my hours to cancel. If I want those to cancel, where do I put my hours? Top. That's what makes this a little bit different. We've been putting things in the bottom to make them cancel, but now I had to put it in the top. So now, what do you want to go to from here? Seconds. A lot of people want to just go to seconds. You could go to minutes, and then from minutes go to seconds. You could do 2 steps if you want, but a lot of you are probably thinking, I know this, 1 hour, how many seconds? Good. What's that, 60 times 60? So this class wanted to go ahead and just skip that additional step of going to minutes, and we just went ahead and went to seconds, which is perfectly fine. So now our hours cancel, and we are left with seconds on the bottom, which is exactly what we want. So we know that we set it up properly. Plug it into your calculator. I'll give you a second to do that. Okay, so 3 sig figs, what'd you say? Perfect. 7.82, and that's kilometers per second. Remember, we're about to take a quiz here. Remember that if you do not round to the correct number of sig figs, you will get points off. If you do not write your units afterwards, you will get points off. And all the way through, you do need to show the dimensional analysis with the units and how things cancel. Okay, so all's good here? Let's do another one. Okay, it tells us the density of gold, 19,320 kilograms per cubic meter. Hey, I did not ask you guys to memorize the formula for density, but I bet you could look at these units. Based on these units, what do you think the formula for density is? Good. So I was hearing mass, because you're looking at kilograms, over volume. That cubic length is volume. So mass over volume is the formula for density, which it just tells us that by looking at our units, we can figure out what the formula was. But again, you don't really have to think about formulas when looking at dimensional analysis, but it's just another little helpful tool if we were asked to look at the formula. Okay, so we are trying to figure out the density in pounds per cubic feet, and we are starting with 19,320 kilograms per cubic meter. Again, I'm going to start with the top. I'm going to try and make my kilograms turn into pounds. Is that reasonable? Yeah, they're both units of mass, so that makes sense. We can go through that conversion. So, a couple different ways that we can approach this entire problem. Not too many different ways in this first part. So, if I want to get rid of kilograms, I'm going to put it in the bottom. What do you want to go to? Grams. Notice this is not given because you guys have memorized this. There were those 4 metric prefixes that you memorized. Which one of these units is bigger? Kilogram is bigger. Right, so the kilogram is bigger, so we're going to say one of these big things. There are 1,000 of those little things. So if we stopped right there, we would have our top unit as grams. That's not good enough. We want to get it to pounds. So let's keep going. We want our grams to cancel out, so therefore this goes in the bottom. What can you go to? Pounds, because we are given this conversion factor. On your homeworks, you have to look it up on a chart, but you've got that conversion factor. So 1 pound equals 454 grams. So we know we got that done perfectly. Again, when I grade these things, sometimes what I'll see is that the units are all set up beautifully, but people grab the wrong numbers. Make sure you don't say that there are 454 pounds for every 1 gram. That's not the case. A gram is about the size of a raisin. Typically, it depends on the density, but think about a raisin as being 1 gram. So that wouldn't make sense for that raisin to have a mass of 450 pounds. Okay, so now we've got it as pounds on the top. We want our cubic meters to turn into cubic feet. You want to get rid of cubic meters. So where should meters go? Top or bottom? Top. Couple different ways we can approach this. Any ideas? What could you go to? Okay, so we want to think about those cubed. We have to deal with that. But what can we go to? What other unit? More than one right answer. Okay, I'm hearing centimeters. What else? I don't typically work with yards. Let's just go with centimeters. That was the main one I heard. I like that answer. Some other answers I was hearing earlier today is you could look at some conversion factors that go between meters and inches, because you've got that written on your homework, the conversion table. But I like the idea of using centimeters. So we want to get rid of meters and go to centimeters. Which one's bigger? Meters. How many of these guys? 100. I am so glad you did not tell me 1,000. I see that so often. So if I just do this once, I'm still going to have some leftover square meters, right? I'm going to have some squared meters down here. So this is when we have to think about cubing not only the unit, but also the number. It's huge to make sure that you do that. So now we see our meters cubed cancel out. We've got our answer as pounds per cubic centimeters. That's not what we want. I should have written smaller. We want to get rid of our centimeters and go to what? Inches. Inches. So Again, we would look this up and we'd see that 1 inch equals 2.54 centimeters. But you have to do it 3 times, so let's cube our units and cube the numbers. So now we've got it in cubic inches on the bottom. Last step is to take those cubic inches to cubic feet. And I did not leave myself room. I'm just going to continue right here. So we're going to get rid of our cubic inches. So where does that go, top or bottom? Top. And go to feet. 1 foot, 12 inches. You have to cube the units and the numbers. So now we see that everything cancels out beautifully. Pounds is in the top, cubic feet is in the bottom. This is where I would recommend that everybody, I'm going to pause this for a second while everybody's plugging this in, but plug it in. Make sure you get the correct answer, because if you don't, then you're making a mistake at some point in plugging it into your calculator. Okay, so here is our answer, and we were just discussing that sometimes it's hard to get from all that work in blue to the answer that's written in red. And the mistakes that typically happen have to do with the cubed units or cubed numbers, so make sure that you're real careful about those things. Also, we noticed in our calculator that this is what we got in our calculator, so we had to round it to 4 sig figs, so we had to make that 0 insignificant. Actually, just get rid of it in that decimal point. We don't need that decimal point. That is it. We have one more problem, and for this, I'm going to set it up. Here it says we've got this gel, which is used to protect these shipments from moisture seepage, and it gives us a surface area. That's not volume, that's area. So the only difference is instead of cubing, it's squared. And what we want to do is we want to figure out what that surface area is in square feet over grams. And we're starting with 6.0 times 10 to the 5th meters squared per kilogram. And the only thing that will make this more fun is if I choose somebody from this group to do this. We will be back. Okay, we have the answer here, given to us right here, and our brainy volunteer came up here and he did a lot of the squaring that was involved right up front in the blue. So you can see some things like this 10,000. The way that 10,000 square centimeter, that comes from the fact that it's 100 squared. Here we have 6.45, etc. That comes from the fact that that's 2.54 squared inches squared. So that's where these numbers are coming from. So I rewrote some of that stuff in black just to show where those values came from. The answer rounded to 2 sig figs is 6500 square feet per gram. That wraps up the first unit.